Welcome to skill development number 2. The focus of this skill development is on 3 videos that are going to take you through a process. One, we're going in and analyzing the landscape to try and understand where we have intact riparian forest cover, meaning that along the streams, where is there existing forest? The second video will focus in on trying to identify the large core blocks of forest land within the Plover River watershed. And the last video is going to go in and teach you how to summarize land cover information. We're going to be using both vector and raster data in this analysis. And let's go ahead and get started. So you can see the instructions are going to walk you through this more or less step by step, and the videos are here to guide you through this as well. And so what I've done to start off is I've gone ahead and opened up all of the available data, everything that I just gave you. And you can see as you go through this that I've gone ahead and symbolized this out, and I've got too much stuff going on the screen. It's almost too confusing. My suggestion is you do the same. Go through the process of going in and changing the symbols, right? You can always change. I've already done this, but you've gone in, say for all my water bodies, so these are the streams, I've gone ahead and told it to be the color of rivers. As I go into my land cover information, I've gone in and changed, so row crops is a light brown, grassland is green, water is blue, right? But again, we have some redundant information, some information in different formats. Just to help you understand this, all of this information, the watershed boundary itself, that's highlighted there in red as I turn it off and on. All of this other information is all vector data, which means it's line or point data that we can use in GIS. The one unique layer that you see in here is that we do have some raster data. Rasters are a grid-based approach to showing or to using imagery, and so in this case it's basically a TIFF file that as we zoom in, what you're going to find is that the land cover is represented as a series of 30 meter by 30 meter grid cells. And so you'll see as I'm zooming in here that the cursor right now over this light blue is in wetland. There's a little bit of forest land mixed into the wetland. As I cross over across the forest boundary, I'm crossing into row crop agriculture. I have a road, so that's urban, right? All of these are represented. And again, it's represented at a grid size of, and I need to always make sure I check my units of measure here. Oh, and it's actually going to tell me in feet. And so what I was really looking for there is meters, right? So I should be able to come in and say 30 meters by 30 meters, right? So each one of these is set up as 900 square meters in size. The reason for this is about the accuracy of the data that we can get to. 30 meter grid size for land cover information is usually about as good as we can get at the kind of broad landscape scale, meaning broad representations of the landscape. And again, at a site scale, that may not be enough. But at a site scale, we could also pull up an aerial photograph. We could go visit the site. We could do lots of things. At a landscape scale, we need a way of summarizing this information. So as I zoom out, what you're going to see is that I've given you the entire Plover River watershed. Right? And it's a watershed that starts off very forested. As it comes down, it progresses through a landscape that is much more agriculture in nature. As you come down further, it actually ends up in the city of Stevens Point, Wisconsin. Right, all of that information's here. I've gone ahead and updated it. So, jumping back to the assignment, I want to walk you through the first step. So, step 1A, how to identify riparian forest habitat. The most important part of this is that we're going to be working with the Plover River boundary. And what we're going to want to do with this is that we want to cut out some data to analyze it. And so in order to cut out data, whenever we're using vector data to cut it down, what we always need to do is we need to use the extract. And we're going to use clip in this case. So what I'm doing here with clip is I'm actually going to use the clip feature. I always refer to this as like the cookie cutter. So that I want the boundary of the watershed to be what I'm cutting. Real quick, I'll turn on those waters, the stream layer here. And what you're going to see is that once I move this over to the side, that'll be my input features, meaning that I want to cut down the water and streams layer to what's just inside of the red boundary. At that point in time, I'm going to have to tell it where I want it to save. And so I will go ahead and for me, I'm going to jump back into a folder I've created for this analysis here. And it's actually hiding one more. There we go. All right, and I'm going to create a new folder, which is instructor. All right, and I'm going to go ahead and label this as Plover River Streams. All right, once I do that, I'm going to hit OK, let it run its process, and you're going to see that it will go ahead and create a new layer of just the water bodies, that the streams that are inside of that red boundary. The next step in the process, once I've got these streams, and you can see it popped up, so what I'm going to do is I'm always going to go ahead and start taking and turning everything off. I don't want clutter on my screen, because then you forget which layers you're actually working with. I can come back in, I can re-symbolize that. So this is all of the streams that exist within the Plover River watershed. The next step in the process is I actually want to create some geometry that will show me everything that's within 200 meters of the stream itself. And part of the reason I'm interested in this is within 200 meters of the stream, that's generally the vegetative buffer that we need to ensure that we're actually protecting the stream itself, the water quality in the stream itself, from surface water runoff. All right, so what I'm going to do next is I'm going to go ahead and run a tool called Buffer. Plover River Streams is my input feature. I'm going to tell it I want 200 meters. I want you to make sure to use dissolve type. I want you to change that to all. And again, you need to tell it where you want it to save and what you want to call it. I'm going to call this Plover River 200 meter buff. All right, everything looks good. Go ahead and hit OK. Let me zoom in here real quick just so that we can show you what's going on. Is that you'll see that I've created that perfect geometry. Anywhere we had a stream that was left inside the boundary, now we know all of the areas are within 200 meters of it, right? And if you ever wanted to go do a little bit more exploration on this, remember you can always go add a base map. You can go ahead and pull in some imagery so that you can actually take a look at what's laying underneath all of this. And so pull up a streaming, that's fine, a streaming aerial photograph. You should be able to zoom in pretty close. It takes a minute to kind of go ahead and load up. But again, you can start to see that, you know, the thing that we're interested in is where do we have forest land within that 200 meter buffer along the streams, right? You can start to even get a sense at this scale where we've got that and where we don't. All right. For right now, I'm going to go ahead and just turn my base map off because it slows down the drawing. And what I will do next is turn my buffer back on. I will go ahead and stop before we move on to isolate land cover by type. Hopefully you've gotten to this point without any trouble.